The Technology Student Association, or TSA, is a national nonprofit career and technical student organization that brings middle and high school students together for their national conference, which was held at the Gaylord Opryland Resort and Convention Center in Nashville, Tennessee this year. And out of the over 300,000 competitors, we're talking to two of the winning teams. So what did it take for the students to design a project strong enough to win at the National TSA Conference? Hello, Circuiteers. The Technology Student Association challenges students with real engineering problems, with every project demanding creativity, decisive thinking, and leadership. These young minds aren't just preparing for the future, they're building it. And this week, we're telling you all about how the Technology Student Association is shaping tomorrow. The American Industrial Arts Student Association is the oldest student membership organization for technology and engineering students from middle and high schools around the country. The organization grew in scale and impact over the years until 1988, when it took on a new name, the Technology Student Association. And with the new name came an updated mission, empowering students to engineer their future through real STEM challenges, which brings us to the engineering design team from Braden River High School in Manatee County, Florida.
The National Academy of Engineering has a set 14 grand challenges. TSA, the Technology Student Association, picks one of those 14 to give to us, which is our topic that we research, and then we create a prototype.
So our prompt this year for TSA was to manage the nitrogen cycle, and we decided to focus on coastal nitrogen pollution in coastal ecosystems. So as a team, we worked together to design this, which we call the bacteria. This is just a model that has been 3D printed in a lot of different parts. But the general concept is that we used denitrifying cyanobacteria in biochar to capture excess nitrates in coastal ecosystems and denitrify them and turn them into atmospheric nitrogen using marine cyanobacteria.
We're both from Manatee County, Florida. We actually experienced a lot of riptide events and other ecosystem disasters within the past couple of years. I know specifically in 2018, when I was just in middle school, we had a major outbreak of riptide, and it made me think, like, why does this happen? It made me start questioning and wondering, and from there understanding that us humans, we have a pretty big anthropogenic way of affecting our ecosystem, especially our aquatic ecosystem.
We won first place at Nationals for TSA.
Now we're traveling to Monroe Township, New Jersey to meet the engineering design team at Monroe Township High School. They've created a solution for a much cleaner future.
This year's engineering design cohort had the prompt for reducing nitrogen pollution.
We have a portfolio that we have to complete, and that contains research that we conduct on our own, so testing our model and also a meta-analysis of other researchers' work.
This is our prototype. So eutrophic water would enter this water pump, which is a diaphragm water pump specifically, and enter from this end. This water, that has tons of algae in it from eutrophication, which is when algae grows in water due to nitrogen pollution, will then get filtered out and come out of this end. On the other hand, the good water, so the water that's been filtered, will be released from this side. The water that's released from this side will be used to water the plants themselves. The organic matter that's separated will be used to power the system that allows the plants to be watered. And on top of this, that water is being injected with a precise amount of nitrogen to minimize the pollution that causes the eutrophication in the first place.
One of my main challenges was making sure that the schematics were accurate and functional. And to do this, Artifuel actually consists of certain pre-existing components, such as a disk filter, microbial fuel cell, and an Arduino.
What we did is that we basically created our own drip irrigation system powered by algae, so it is renewable. Basically made drip irrigations more selective, so that way they release precise amounts of fertilizer.
So that involved understanding what the nitrogen cycle really is and what the issues that come with it are to farmers.
When we ended up placing third, I think it just shows that you're not limited to anything. You know, you think you're limited to something, but you're really not.
TSA's Engineering Design Challenge is built on the National Academy of Engineering's Grand Challenges. These challenges are real problems that still exist around the world. And the students who we introduced you to today are definitely building powerful and promising solutions. Let's take one final look at the future of engineering.
I love engineering because in engineering, we design novel solutions and assess its effectiveness of enhancing our world.
I love engineering because
I just love the thrill of finding solutions to problems that directly impact our society.
Engineers make the world go around.
If I had known that you can choose a problem or choose a topic that you genuinely really care about, and you can go forward with it and make it an actual engineering prototype that can help or solve this problem, that is incredibly validating. And you don't have to be an actual engineer to do that. You can be a high schooler or a middle schooler, and you can learn and you can try and you can research, and it's gonna happen and you're gonna grow through that experience.
And if you enjoyed this week's episode of the Circuit News, don't forget to like, follow, and subscribe for more incredible engineering. And a special thank you to the Ming Hsieh Institute at USC Viterbi for making this episode possible.